Welcome everybody to Robot Builders Night Virtual for August 20th. As usual, we'll go around the table and update people on their projects and what's going on. And after that, we'll just do ad hoc presentations if anybody has any questions or has something to discuss. As usual, our meetings are recorded, so if you don't want to appear in video or be heard, make sure you keep your microphone muted and your camera off. With that, I guess we'll start with the Iron Rain group and Kareem. They want to start the presentation.
Jay's gonna kick it off.
Okay, so hello everyone. My name is Jay. I'm on the code team for Iron Rain, and it's me that's screen sharing. Yeah. So if everyone else, can you all see the screen? Okay.
Yes, I can.
Okay. So I'm gonna get started in just a second. And in the meantime, Arav, Fernando, do y'all want to introduce yourselves?
Yeah, hi, my name is Arav. I do a lot of the documentation, so like our engineering portfolio and some of the presentations for Iron Rain.
I'm Fernando. I do CAD and build parts.
Cool. So let's honestly get right into it. So yeah, as y'all probably know by now, we're Team 6832, Iron Rain. And this is just kind of going through some of the stuff we've done this summer. It's been hard to follow up our projects from last summer, what with like automating an excavator and trying to do some crazy things with an RV. But this year we've kind of focused on smaller scale projects that we can really apply to like our game robots and our competition robots.
All right, so our first project is a swerve model we decided to sign. The main reason for this is we wanted to build something we could integrate into our competition robot or for our like preliminary robot for competition whenever the game gets released. And we've tried to do a lot of swerve modules in the past, but this is our first attempt at actually, polishing it, going through lots of iterations, and hopefully releasing it before the actual game releases. So the main components of our swerve design is the actual servo, which concerns the steering of the swerve module. The motor controls the actual translation of the module and the robot it's attached to. And it's a custom designed servo housing and motor mounting. So it all fits onto this rectangular plate, as you can see in the diagram, but it's made to be customizable to fit whatever chassis you decide to run for our robots.
So we really got the idea to start out from another team swerve module that we thought was cool on Discord. And then we were like, hey, that looks cool. Can we do that? And so we started kind of with two separate pulleys and the kind of general shapes that we wanted our modules to look like. It's modeled very heavily after like shopping carts or like the rolly chair I'm in right now, those kind of wheels. The sketches are super rough, but they're always helpful. And they're our first step in our engineering process.
So this showcases our move from version 1, which is incredibly simplistic and doesn't even account for servos or motors, into V4, which is a fully functioning swerve unit that has its own standalone swerve servo module, and it's been optimized to have the shortest distance between the servo and the actual wheel part. And we have a 4-part wheel instead of the 2-part that we had originally. So this is our version 1 of the swerve. Originally, we went with having 2 pulleys. The bottom one that's built into the whole thing would control the steering, and the top one would be powered by a motor and control the translation. We quickly moved away from this design as it was incredibly inefficient due to the excessive amount of turns needed. If we use a smaller second pulley, or if we use a more appropriately sized pulley, we'd be taking up way too much space.
This is our second iteration. We still don't have a way to steer, but we have moved away from the large, inefficient pulley. And at this point, we're still working on figuring out how to mount the motor and how to steer, but we're kind of getting places. And then finally, we figured out a way to control steering using a steering cap. It has a pulley built in for an external servo to control, and it also serves as a way to kind of grip onto the whole module by sandwiching the bearing in place. This was also when we started to transition to a new type of wheel core, which had 3 custom parts instead of the 2 we were previously using.
So here we have our whole unit / module. We've wanted to make sure that we can implement it into whatever kind of chassis design we chose. So we optimized the center to center distance between the swerve module that's on the right and the wheel module that's on the left. Additionally, we've also changed from a positional rotation servo into a continuous rotation servo, so we could have infinite range for our steering. And because of this, we've added the rev throughbore encoder, which you can see at the bottom, the little gray piece, in order to get positional data for that. So we've talked about the wheel throughout the slides. Now we're going to kind of dive into what we actually did. Originally, it was only 2 parts, the core, which was made out of PLA, and the tire made out of 95A TPU. Now we have a 3-part nylon blend core and a tire made out of 85A Ninjaflex TPU.
And then for the code, we also decided to take a similar approach where we kind of build it from the ground up, taking vague inspiration from other people. So at the very, very beginning, like around V1, V2 of the physical iteration, we were literally just like, okay, this joystick makes the motor go, and this joystick makes the server go a little bit. And then now we're at a point where I can flick the joystick one way, and the motion of the rotation is kind of mapped directly to the joystick. And then our other joystick kind of controls power to the motor. So it's a way easier way to drive. And then we plan to kind of move forward with this. This is where it's at right now, to where it's literally just one swerve wheel and then a bunch of omnis around it. And so I'll flick the joystick and then kind of ramp up the power. And that's what you're seeing in this video right here. Eventually, we plan to move towards, of course, smarter implementations of swerve. One that maybe accounts for like, oh, the robot is oriented this way and I'm standing here. Relative to me, how am I supposed to be driving? All of that math and implementing more servos, more components, all of that.
So we run into many problems when it came through the design process of our swerve. One of the biggest ones and most recent ones was leaving it in a car in the Texas heat. As you can see, kind of deformed and melted a bit. So we've moved over to nylon for most of the parts. And then we've also found that there's a lot of tolerance issues and just metal on plastic contact that kind of tears away and stuff. So we're changing stuff up for that too. We've switched from a 2mm pitch DT belt into 3mm. And we've mostly moved away from 3D printed pulleys. However, we still have the one for the steering cap. And while we don't have an exact number, we're thinking it's been about 56 different parts throughout the whole design process.
However, there's still a lot more we want to do with Swerve. We want to turn the large base plate into a rigid one, and also reduce the size of the overall Swerve module so it doesn't limit our chassis options for the upcoming season. For now, at least we want to plan to release a full, assembly instructions, like how to build a Swerve, along with a full bill of materials if anybody wants to replicate it.
So our second wacky innovation was the RoboSpine, a spine that we can use on a robot to give its motion more flexibility. We gained inspiration from an old string-controlled track we found laying around in our workspace and modified it until we could make a standalone subsystem based off of a spine.
So, as Fernando mentioned, this started when a couple of team members started playing with a cable chain, and we created this unfolding extender, as you can see on the left. So the person in it is Sol, and they did a lot of the work on RoboSpine and designing it and taking it through its iterations. They unfortunately can't be here today right now. But after we created this, we were advised by Mr. B to think about how we can use spines in invertebrates and how we can apply those to robotics to make more flexible robots. So biologically, spines are pretty complex, right? They have lots of individual vertebrae linked together with things like cartilage, ligaments, discs, tendons, and muscles. Each vertebrae is also slightly different. We started exploring how vertebrae can connect to each other to find ways we could replicate this using parts we had at our workspace, along with parts that we could design and manufacture.
our early attempts kind of looked something like these vertebrae. And so we had kind of multiple hinges for motion, but then we figured out that this got pretty messy pretty quickly with all the hinges. And so a lot of them ended up snapping because we 3D print the whole thing. And then we moved on to a second version that had stronger hinges, but because it had stronger hinges, the range of motion was super limited, and then it made it just less useful. And so we kind of decided to go back to the drawing board and start studying human spines and how they work, and maybe that could yield some new results. And so when we did get there, we noticed that bones are like tubes. And so we decided to kind of model our robotic spine after human spine and create kind of cylindrical bones with simple links in between. And so we did goof up again here. We started with a design that was meant to be printed in nylon, and then we realized that nylon wasn't flexible enough, but then we were like, printed in TPU was the worst that could happen. The worst happened. The supports were impossible to remove, tolerances didn't work, and so we were like, this sucks, we're gonna move on. And so we moved completely away from hinge-based joints and multiple track linkages into something kind of new again. So once we get back to the drawing board, basing our robotic design off of a biological spine was kind of the way to go, but we had to find a way to create better joints. So last year, or last year, I guess. Wow, mold. Okay, last year, we worked with these kind of yellow poles that we had to put cones on. The veterans remember, but and so we realized that these yellow pole pieces kind of looked like the same tubes that we were studying in human spines, and these could operate like the bones in the vertebrae. And then we figured out how to connect them with basic kind of flexible plugs. And so we printed those out of PLA, and we made the interior of the plugs hollow so we could run kind of wires through them. And we created grooves in them to run the wires through and that whole thing. And so you ended up with something that looked a lot like this.
So this is
Plugs
RoboSpine.
for TPU, by the way.
So this is RoboSpine. The yellow tubes are the ones that Jay mentioned from the past 2 seasons. And the red things are those TPU plugs he was also talking about. And everything is controlled by 2 strings that are actuated by that servo at the end. These are the flexible TPU joints. They were designed to plug into our tubular links using 3mm bolts to lock them in. There are tendon string guides right there. You can see it on the first picture near the bottom, which allow the string to pass through. There is a passage for routing wires through the spine, so we have neat and orderly cables, no spaghettis, hopefully. And the joints have features of spinal joints. Shock absorbing like discs and ligament stiffness can be dilated by adjusting infill and wall thickness. But unlike our normal human joints, there are no rubbing components. The bend has the preferred axis aligned with the differential tendon pull, but is compliant to external incidental contact.
The rigging uses kind of high strength polyethylene. I think it's rated for like 3,000 pounds or 300 pounds, something crazy.
300.
And it's threaded through these 300 pounds. And it's threaded through these tubes and joints of the spine. The spine is then used like a tendon. And when you pull on the string in certain ways, it contracts both ways. There are 2 idler spools that redirect the spine, kind of the cable, so that the spine gets pulled one way and the other way. And then we take up slack using these rubber bands at the end, because when you kind of pull it upwards, you have to manage the slack that's on the other side, and then it gets really messy really quickly. So we use rubber bands for that.
So here we can just kind of clear up what Jay had mentioned. The inside string contracts in order to bring in the spine, but then there has to be slack on that outer string in order to allow that motion to happen. So here at the end, by the nylon piece or that white piece on the right, that's where we've placed the rubber bands.
And so here's Inchworm. He's a prototype RoboSpine robot. This isn't really like competition ready, but it's more of a proof of concept for what the spine can be. So after we worked on spine and got some working, we started thinking more of like the pros and cons of this design. So first off, it seems really impact resilient, which is really useful when you have robots hitting each other during matches, and it has a wide range of motion and can fold. So it allows the robot to, I guess, contract for the initial sizing and then expand once match play starts. It's also good with our servo allotments because it moves in 2 directions while only being operated by 1 servo, and the cable management is integrated into the yellow, into like the, I guess, the yellow poles and the joints we made, like mentioned earlier. However, it's not really strong, and we really haven't tested how much it can carry, especially when you have to add things like batteries and control hubs and all the other things we want to add. And despooling also hurts its reliability in matches. And so with this all in mind, there's a lot more that we do want to do. First off, we do want to add more joints to the actual spine and make it longer. The joints also don't have the springiness that we would want. So we want to experiment things like inner wall widths and infill until we get the perfect joint. And now, of course, yellow isn't really our aesthetic, so we got to make it black and red. And we also just want to work on testing more functionalities of the spine, because a lot of it is also to see how the spine interacts and how we could use that in future robot designs.
And finally, to fulfill Mr. V's longtime dream of being able to have like some kind of robotic hover beanbag chair, we strapped a lawnmower to a sheet of plywood and kind of taped the garbage bag underneath. It's an oversimplification.
Not a lawnmower. You said lawnmower.
Or not a lawnmower. I misspoke. A leaf blower. My bad. A leaf blower to a sheet of plywood, and then taped a plastic bag underneath, cut holes into it, and kind of had to tune it back and forth a couple times. But you can kind of see in that bottom right corner where we ended up. And this was able to carry the weight of a sort of light person. We actually demoed this at the Frontiers of Flight Museum. And I think a couple of y'all might have saw us kind of put kids on it and drag them around. They would start screaming, but it was like really fun because they were super light and it was super low friction. But yeah, that's a thing we did because we thought it would be funny. And yeah, that kind of wraps up our what we did over the summer. Some more useful and sane like Swerve, some less useful and less sane like this hover pong. And actually, we kind of have plans to turn it into an actual Pong game. So we'll see where that gets us.
Yeah. So,
Thank you very much, guys.
Yeah. Is the Swerve a competition, like a one-wheeled robot, or what's driving the Swerve?
Fernando?
Sorry, could you explain what you mean?
Oh, what is driving the Swerve? Is it just for fun, or is there a competition you're trying to do?
So initially it was more just for fun, but we've definitely seen its applications and are trying to get it ready for our for the Robot in 2 Days challenge we do once the season reveal is done. On the weekend, sorry.
Yeah.
So you know in FTC that the vast majority of robots these days are Mecanum drive, because that works really well on those mats.
Mhm.
But very few teams have Swerve drives, partly because the cost of the components is higher, the complexity is higher, and there's also a limit on the number of motors that teams can use. And so your typical Swerve drive robot actually has 4 Swerve modules on it, and each of those modules requires 1 motor for driving the wheel and then another motor for steering the wheel. And typically you use the same full-size motors for those. But we've got some high enough power servos that we can use for steering. And so the minimal, I also like them to like focus on just sort of basic research during summer projects. It's great if it turns into something that is potentially functional for the season, but they're sort of exploring, how do I design these things from the ground up, because then they'll understand it better as opposed to trying to buy an off-the-shelf Swerve module. But the benefits of Swerve is that it's basically that so with Mecanum you're losing some of the power at all times, especially when you're doing sideways movement. Whereas the swerve, you have your drive motors applying full power all the time. And so, you know, they're trying to figure out how many of them that they need, because you also don't actually have to have 4 swerve modules on a robot. You could get away with fewer. And so the mono swerve was like, what's the minimum we could get away with, right? And you can actually drive around a swerve module with just one robot with just one swerve module, but you lose control over the orientation of the chassis, right? So you can drive in any direction, but the direction you're facing might be different, and that can also be disorienting. So, you know, they're also figuring out things like what are the algorithms for controlling it in field orientation so that it's easier for the drivers to manage.
Yeah, because I thought it was interesting. There was only one motorized wheel, and how many casters does it have? I guess the other wheels are considered casters.
Yeah, they're just Omnis configured as.
Yeah.
They're almost acting more like ball casters.
So why do you
That's
not use
interesting.
a ball caster instead for the other wheels?
Because we've got tons of Omnis.
Okay. Simple answer. Okay. I was just curious since you brought
Yeah.
up that.
We don't have any ball casters, but we've got tons of Omnis. Just because, you know, it's part of the inventory, the kits.
Right.
There's another kind of drive called the Kiwi drive, which is Omnis in a triangular star shape arrangement. So that's another type of robot. Very few teams use those because they can be pushed around so easily. They're, you know, and there is some contact in the games.
So the benefit of the drive versus Omni would be you get more push power, I guess is the term I want to use. Is why you're thinking that?
Yeah, basically you get the full speed and torque range with swerves, multiple swerves, and you don't get that with any other thing that's also holonomic. At least I don't know of any other drive system that'll do it.
Does the spine have any application in a possible application in a contest robot?
That's I think they're very early in that. What do you think, Jay?
I think it definitely has some potential to win some design awards at the very least, because it does just be like, whoa, look at that. But as far as performance, I feel like it still has to be tuned a lot. I don't know if y'all were all able to catch it because it was only on screen for really a couple seconds. But yeah, this is kind of where we're at right now as far as competition readiness with the spine. Yeah, that's the battery taped on. So we're in
what
very.
function would it serve in a competition robot?
I guess some kind of like extension further than linear slides could maybe. And it's only one actuator and bidirectional movement, so some kind of interesting degrees of freedom that could come out of that. I'm not too sure, honestly. It was kind of a fun project.
In this configuration, you can't really see it, but it has the ability to bend the other way as well. So in that case, it would be like lifting the front wheel up. So yeah, it can go either direction. It might be more of a analog for an arm than a spine, but you know that's.
Yeah, I could see the arm, but one thing that I think a point that you emphasize as a benefit is that it only has one actuator and potentially multiple segments. But it becomes, I think the term is under-actuated, in that if you have more than two segments, so you have two joints, for example, and only one servo, then you can't control the angle between the two joints. I'm just curious about your thoughts on that.
No, that's absolutely right. They haven't experimented with it much. It's hard to tell on this video, but there are actually 2 joints there, so there's 3 segments. It's just that the chassis is attached to one of them, so it's already under actuated, and so you're trying to control the relative bend of each joint more by observing the loads, I think, that are on it, and the stiffness of those plugs. So they've printed them in a bunch of different infills to get a different kind of stiffness, and that basically gives it also a way to sort of want to snap back to being straight, since it's inherently elastic. But yeah, you don't have as much control as you would have like a fully articulated multi-degree of freedom arm. But it's also much simpler and cheaper, and you can get some pretty good reach with it.
Thank you.
Question, Kareem, this is if you wanted to control the different joints differently, could you just run more cables?
Yeah, we've talked about that as well. There is room for multiple wires to go through, and you could have multiple actuators. In this case, again, we're just using a servo, and it's there's 2 spools, and they're wound in opposite directions. So that one actuator can bend it, that way or the other way.
Yeah.
And if you want to individually control, then you can put more actuators up and then string the wires differently.
Okay, I was just saying that you could probably overcome if you wanted the joints to bend differently.
Yep, you
It'd
can.
be more complicated, but you could still do it.
I mean, in a way, it's really just a flexible joint, and it's we still call them tendons. The strings are just and the actuator is equivalent to a muscle, and whatever you pull on, it's going to contract, right? And so it's very similar to. I would call it biologically inspired, if nothing else.
Okay.
Did you guys ever have any interest in?
Before you guys go on, I just wanted to ask another question because I've been playing with something. I know you use a lot of different materials on your 3D printers. Have you played with ASA?
I have not. Fernando, have you?
I haven't heard it's better than ABS though.
Oh yeah, I've been messing with it this week, and I've been impressed. It handles much but easier than ABS, yet it has the high temp stuff. You have to run it very similar to ABS. You got to have, I think the extruder, I'm set at 255 and 110 for the bed, so it's pretty hot. And it helps if it's in an enclosure. It doesn't have to be a heated enclosure, but because your thing will heat up by itself with that much heat going off the bed and everything. But it looks like it doesn't crack as bad, doesn't lift off as bad. I'm just using blue tape. I'm not even using glue on it. I mean, it's pretty amazing.
So it's more rubbery light you're saying, or is it?
No, it's. I say it, and it smells better than ABS. I would say it's a alternate ABS.
So it's
Right now, that's how I'm treating it.
It's
With the
still
benefit-
rigid.
Okay, it is rigid. Okay.
Yeah.
Could I make a comment or just talk about the material we're using for our swerve?
Sure.
So the black PLA, the black nylon you saw, it's Co-PA by Polymaker. It's a blend of nylon 6, nylon 6.6. I'll be honest, I don't know the full scope of how it's better, but it definitely prints easier than the alloy 910 that we typically use for Iron Rain stuff. It's also 250 to 270 C for a printer. And print bed, I run it at 30 to 40, and it prints incredibly easy. And I rarely have any flaws whenever printing, and it also smells much nicer. Doesn't smell too bad.
Can you put the name of the filament or a link if you can get, if you have it?
Yeah.
Yeah. Because
So are some of the mechanical components Go Builda, or are they Rev, or like the motors and the gears, or?
For the swerve, we have Rev, GoBuilda. A lot of the some of the axles and bearings are GoBuilda, and the servo and the through-bore encoder there, plus the motor are all Rev. And we have a bunch of 3D printed parts, and the big bevel gear and the small pinion bevel gear, those are Axon parts.
Haven't heard of them before.
Axon's pretty small and they're catered specifically to FTC. They started with some higher powered digital servos and with analog output, so you can actually tell what the orientation of it is. And they also have some other cool products, and like this this bevel gear arrangement is new, so that's what's driving the main wheel here.
Okay.
And
There's
Fernando did pretty much all of the design on this one.
Okay. There's a talk about like simulating biological parts. Have you ever seen the kind of looks like an elephant trunk that's actually pneumatic, and it has different like chambers, left, right, up, down, that if you pull or push, it extends it left or right or up and down. Any interest in that, or did you guys look at that too, or?
Yeah, we've seen pneumatic muscles, and I don't know if I've seen one that's a trunk, but I've seen things like snakes and other things that are like that. So they also sort of mimic spines or multi-segmented flexible things. But our problem is that pneumatics are not allowed in our competition. So we tend to stick to the things that we could actually end up using.
Huh.
They're allowed for FRC, but they're not allowed for FTC. We had a lot of previous members who are just dying to get into pneumatics because it's fun, but yeah, we have not invested in those kinds of parts.
Jay, Mickey wanted to know, do you think that it could climb stairs?
Oh boy. In the current state, if at all, it would be incredibly slowly. I don't have much faith in it in its current state. I do think that possibly eventually. What do you think, Mr. V?
I think that's more a function. I think it's probably tunable to make it possible, but you probably wouldn't be able to use servos for that, right? So it's more of a power budget thing than anything, probably. So it's a power to weight ratio problem when it comes to sort of climbing upstairs and things like that. So I don't know, but there's nothing that says we have to use a servo as the actuator. It's just a spool, and it can be turned by anything. But then you get a heavier motor, and I would say it's from a power budget standpoint, it's a lot easier to go downstairs than upstairs.
I was going to say that I saw a video where somewhere they had one where basically could climb up using that technique of bending the thing, but the catch is they had a motor on both ends, so effectively it would pull itself up.
Right.
And so that's why I would say that would be the problem with this, is that unless it can get good traction on the side of the wall, it's going to have issues trying to get up the set.
But that is one of the reasons why we started looking into this in the first place. Not specifically for stair climbing, but for just the ability to think about having a different way to approach obstacles, vertical obstacles. So
in the contest, well, I don't know if you know what this year's version will be, but I know in one year y'all had where you had to go put things up high up in there, so being able to reach up, literally crawl the wall. I could see the benefit of that, being able to reach higher for that reason.
There's a lot of speculation. We don't find out until September 7th is the new challenge release, but there's speculation that it's been a while since we've had like obstacles on the field. We did have a climbing challenge at the end of last season, and you can sort of infer some things from the like the cost of the field sets, the way it's balanced this year. There's gonna be some central structure so the last time we had a big central structure, the robots started out hanging from it. So but and then they also had like crater walls that they had to get past. So there's a possibility, but there's also a new change to the rules this year. We can't have the super long robots that we've had in the past. Was it 42 inches is the maximum extension that the robot can go to now?
Excellent, guys.
Very good.
I really appreciate that. I don't know if there's any other questions for the Iron Rain group. Thank you very much for presenting. And we've given you guys a couple gold stars in our, it'll be on the web, on our website, and we appreciate it.
Thanks, guys.
Thank you.
Thank y'all for the opportunity to present, and yeah.
Well, we love hearing from you guys. So anytime you have something to present, we're eager to watch and listen.
Yeah, and when they do announce the course, I'll be curious. So if y'all want to come back and describe it and that, we appreciate it.
Thank you.
Okay. Next up, I think we had Doug P.
Okay, let me give a second here. Okay. What I came across this link, and I really didn't know what I was getting into. And then, every once in a while, and you find something that you think is a real golden egg. And I think this one is, these set of links might be a golden egg. So I don't know why I was here, but I was here. I was looking at the Homebrew Robotics Club out of San Francisco. And they had a link that was right here. It's part of, this is one of their Give Me a Drink for Refrigerator contest. And they had this set of links here. All right. And it starts off as behavior-based robotics. And they start off at 2.5, but I think he's a professor, but he might be just a talented individual. But anyway, it actually starts at something like 1.1. And if you go through these links, you'll get to this one and they suddenly get broken. So what you have to do is
You're not presenting anything as far as I can tell.
Oh, I'm sorry. Well,
and there isn't a link in the chat.
No, give me a second. Oh, dang it. And I blew my whole speech. Oh, well, I'm going to go ahead and here do the entire screen. Boom. Okay, here we go. And
you're going to have to practice a little more like the Iron Rain group does.
Yeah, you're going to have to. So this is, like I say, this is out of their homebrew robotics club. So these links down here, if you flip to one of them, starts off, and you can see they're all about 8 minutes long. And when you get to the broken ones, what you need to do is go down to his channel, open it up, and go to his videos. Because I think why they got broken was he redid them. So, because if you follow here, like you can see here, he's got 6.4 that's out of it's out of order. All right, all of these are out of order. So I believe those are redos. And if you look at these titles, and I'll try to get down, he started at, where it is. Okay, he started at, no. Okay, some. The fact that they're not in order kind of makes them a little bit harder to follow. But essentially, the ones that I was looking at are obstacle avoidance. And he goes in and he starts off with very basic obstacle avoidance. I'm trying to find it. Okay, I think this is the first one. And he talks about it. Well, in behavior, you have two. One is go to gold, and one of them is to avoid. And that doesn't get you, that actually doesn't get you, a lot of people start that way, but it doesn't actually get you anywhere. There's too much, there's more to it than that.
Can you try the playlist tab? It may be in a preferred order there.
Yeah, that sure would be nice. Give it a shot.
Robot control, Coursera.
Maybe, we'll see. No, that doesn't.
On the right.
I mean, where's the right? Oh, okay. I see what you're saying. I want them to talk. Yes, this is probably the way to go. You're right. That's it. So anyway, he goes in there, and there's some things that, like I say, I was really interested in the obstacle avoidance, and
that's 2.8.
Okay, obstacle avoidance. And when he got into this, like I say, essentially he builds it up and he says you essentially to be able to handle convex and I think it goes all the way up to 6. He talks about hard switches versus blending, and then convex and non-convex worlds, and then he basically says you need a third obstacle avoidance behavior, which is going to be wall following. And then when he goes through all of this stuff, he's actually developing the math and showing you how you handle the problem of, okay, when do you stop wall following and what direction do you start wall following? There are actual solutions to those parameters. And he goes through that. And then he talks about, well, and he gets up to 6.6 here, and that's he does the whole math, and it's a little confusing at that point. But if you follow it, it's done in nice small steps, and the math isn't crazy bad. Okay, and he also then talks about, well, when you get there, you basically there's a couple of little things you have to tweak, and then there's and you just have to tune it. But it's a very good explanation of obstacle avoidance. So I guess this is the playlist, so I'll just copy it and put that in the chat. But you can always go to find it on the homebrew thing if you get there. So I just wanted to share that because I found it to be very good. Okay. Anyway, that was all I really wanted to share, and that's all I really wanted to cover tonight. So, go to Mike.
Well, thanks, Doug.
Mm-hmm.
Hey, Doug, have you played around with the Max Cam at all?
No, I've got a secret project that I'm going to probably report in a couple of weeks. That's been it's got me really excited. I've been dumpster diving and got something, and it's turning into a robot. So it's kind of cool.
Yeah, I heard that. I don't know if it's just the state of Texas, but I think Abbott outlawed dumpster diving.
Well, I don't know. It's picked off the curve. Is that dumpster diving? I guess not officially. There's no dumpster.
Not in a dumpster, I guess. So.
Yeah. But somebody put something out and it's cool.
But it's a secret.
It's a secret at this point. I'm working on the motors right now.
Next up, Mike.
Yeah. Well, I've been talking about this robot for my theater, not the ball robot, but the one that's supposed to move a puppet or a statue around in a crowd. And then the last meeting we had, not this meeting, but the theater meeting, they started talking about they want a real chaotic scene, and I was planning on using my car platform, but cars move in a real predictable manner. So I said, okay, I need a mechanism wheeled robot. And so and for the theater, it has to be extremely reliable, and it has to have a lot of safety features because it's going to be running around with the audience in a crowd. They're not sitting on a chair or anything. They're walking around. And so I decided to use GoBuilda as the platform. And so I bought the parts and put it together, and it went together really fast. I'm going to show it here. So I can show it as just the you might want to pin this, but it's a mechanism wheeled robot, and I put it. Let me hold it the other way around, get more of a balance. And so so basically on the bottom side you can see this is just a standard build from a kit from GoBuilda, and so it's really nice. And Iron Range used these before, and it's real solid, inexpensive.
So did they totally fund you on this or what?
Oh, they'll reimburse me, yeah.
Oh wow, man!
And so I'm using the Rock Claw,
RoboClaw, yeah,
RoboClaw, I mean, and I'm using a mechanism mixer and a receiver here. And so there's a RoboClaw here for the wheels on this side and a RoboClaw for the wheels on that side.
Yep.
And what I did custom though is the power. I need a minimum of 2 safety features. One is a switch here. You see at the very front. It'll be mounted on. Oh, let me talk about this for a second. See these posts here I added to the frame, and there'll be a circular platform on here, and it'll be a big circular bumper around it. And so if it bumps into anything, it'll stop until whatever it bumped into moves. And also if things go haywire, I put a big relay here with a fuse and a battery and a emergency button right there. And the emergency button will be mounted on the top so that someone, hopefully will take and hit the button if it goes haywire. So, and I decided to use the battery from my car robot platform. It's a really nice battery. So I had to do so I just did this wiring here is the custom stuff, and right here, and then this right here is all off the shelf. So
Mike, what's going to be the cover? I see the 4 corner posts. I assume there's going to be something on top of it.
Yeah, I'm going to take classes so I can use the woodworking equipment. So I got to cut out a round platform, and then cut out a ring and attach the ring to the platform so it moves, and has a foam bumper around it. And so if it bumps into something, it'll hit a limit switch and it'll stop the motors. So these are just to hold the.
Is there going to be any decorative, you know, like a clown's head or anything on the top?
Yeah, a puppet on it, a statue puppet. Yeah. Oh, they're going to put a so we're going to talk about that tomorrow. What are they going to put on it, and how big does this platform have to be?
Gotcha.
Yeah. And I'm not designing that. No.
Yeah, gotcha.
And do you get to keep it all after it's all said and done, or what?
I can probably use it, but it's going to be used. It's going to be but basically it has to be really reliable for multiple performances, because these aren't cheap, and it's an integral part of the whole show.
Mm-hmm.
And it's going to be traveling out to 2 or 3 or 4 cities over the years. So
you're not going to be keeping it then? Oh well, darn.
I mean, they're going to have to store it, and if they store it at my house, then I can play with it, right?
There you go. There you go.
Yeah. So I can get the gold star.
Okay, go for it.
Going for the gold star here. Okay.
Right. So I can turn it on.
Yeah. What do you think that is, Kareem? About $600 or $700 right there.
Oh.
Well, he showed me the purchase list, so.
Oh.
But that, yeah, it's pretty pricey. It's beyond that.
Oh, it's beyond that. Wow.
Mm-hmm.
Oh yeah, it's so you can see it. It does its own Canon thing. So it's quite functional. So I got the basics done. Now I got to figure out how to control it in a manner that they'll be happy with.
So Mike, there's going to be a pilot, right? It's not going to be autonomous.
Oh, there'll be a pilot, but I might put some pre-programmed moves that I can just hit a switch. Like this controllers. I haven't used one of these controllers before.
Oops, that's probably me.
Yeah, we lost you.
And different commands. That can a mixer, which is a standard off-the-shelf part, with a computer board. And maybe I can let it do some more complicated movements, because it's hard to do a real complicated movement, because I want to be able to have it go in a straight line while it's rotating, and I can't do that with these controls, because it's a big complication thing.
Yeah, I could also see where you might want some sort of movement in the puppet, like, it waves its hands or it does something unusual.
Yeah, I'll find out tomorrow. I hope it's just static, but I'll put lights on it and a speaker on it to make sure that people pay attention to it and can see it and stays out of its way. Because, like I said, a large building, like an indoor gym or something would be about the size, and it's
Throw another quarter in.
And so people are there, and then the actors and the robots just intermix with the people.
Yeah. Okay, so on this, just for curiosity's sake, the stage itself, is it a stage, or is like a rest area, or is it just the center of the room?
It's a big open room, like I said, a gym, a high school gym or something. It's not a high school. At the women's building in January.
I thought I had bad internet.
Beautiful building on the open space. so it's going to be good. So basically, I have my platform done, and now Oh, one thing I was going to ask the in safety feature.
Mike, you're breaking up really bad. Your video is like half there.
Emergency.
Mike, maybe you could turn off your camera for a bit. It might help with the audio.
I think I lost connection.
We didn't hear just about any of that.
Yeah, you've been breaking up
Mike.
really bad.
On the screen,
It's been breaking up.
I had a big thing on the screen that said my internet was missing. But am I back?
Yeah.
You're still dropping.
Uh,
So you're freezing a lot. You might want to drop your video. Turn off your camera. Try talking now. Of course, now we can't tell if
Is
he's
that better?
frozen. Well, we heard that.
So far.
y'all are frozen too, so why don't we go to the next one and I'll
Rejoin.
Fill in the blank.
Yeah,
come up later when I figure out
I
what's
think you better, Mike. We're losing you still. Next up, we had John.
Yeah. So this will be an interesting little thing. We were talking a couple of weeks ago about 3D printing and orientation and strength of parts and stuff like that. So on my Columbus robot, I have a 3D printed mount on the back for holding my IMU pole. And lately I've been kind of tossing my robot around a little bit to, try and sort of simulate rough handling that it'll, undergo when it's driving across yards and whatever and hitting bumps and stuff. And so interesting thing happened, just tossing it down from like 1.5 feet up in my workshop here. The part that I'd printed actually, well, it didn't break that far, but it's broken. And of course, when I printed it in this orientation, and this is ABS, so it's fairly strong regardless, but of course it broke. So I thought I'd show what I did to fix that. And so let me share my screen. Well, share a window. And this sort of goes into what we'll be talking about on Saturday a little bit, but so this is the CAD model that I have for most of the parts on this robot. So you can see, it's got the roll bar and it's got the sort of the loop mount that mounts the Raspberry Pi 4, and then there's the PCB that has all the embedded controllers. This is the electronics battery that sort of slides into this space. I haven't modeled the whole truck, obviously, because I don't see any reason to. These are just the parts that I print. And this whole assembly back here is the mount. This piece here is what I call the mast mount. And it is the part that broke. So what I did is I decided to print it lying down instead of standing up. So it, of course, will have much less tendency to break in that direction now. So I made the back of it, and let me just turn off everything else. So I made it so that I could print it on this surface here. So it prints like this when I put it in my slicer. And so I made this surface be flat, basically. And, it's got some overhangs that it prints with support, but that's no big deal. And I added, because these parts here are now going to be sticking up with the sort of the I don't know what you call it, the layers going horizontally here, they're not going to have that much strength. I mean, they'll have some strength because they're sort of in a metal channel for the chassis, but I basically just took the vertical thing and made it go up at a big angle. So now it's got a lot more meat to it, to this one part here. So it'll be much less likely to break in that orientation. The only real issue that I might have is there's a line basically from here and this plane here, which are basically in line. So it may end up cracking along that line. So I may have to do something about that, but we'll see. So I ended up, I printed that, and let me turn off my presentation here. And it is now mounted back on the back of my robot here, and much stronger in that direction now than it was before, because of course the layer lines run vertical now instead of horizontal. So anyway, that should be a fair amount stronger. So I'm pretty happy with that. The other thing that I have is the battery just slides in here and is stopped by the big wires coming out, but there's nothing really holding it here. And I used to have a clip that I printed. Oh, here, I'm just going to pull this whole thing off here. No, not magnets. I used to have a clip that I printed also out of ABS, and it basically just slides over top of this thing and clips in place like that, and that holds the back of the battery from, you know, and that's fairly strong. You have to sort of flip it off of the end here to get it to come off, because it has, you can just see, if you look, you can see it's got a little hook on each side, and that hooks around this piece. So that holds it really well. But of course I can't use this now because the angle of this thing goes at an angle. So I'm in the process, I printed one of them like this, and it also has the little hook on the end that you can see there. But the problem with this one is, of course, when you put it on there, and it clips nicely in place, but there's nothing stopping it from moving up and then just sort of sliding off, because this thing's at an angle now. So as soon as it moves up, it's not holding on. So I'm in the process of adding another one that goes down underneath here as another hook. And I printed one of those earlier. So it sort of looks like this. And I'll show you the CAD model in a second, but it turns out that piece is a little bit too thick. It's not flexible enough. And of course, because I'm printing it this way, the layer lines go that way. So when I tried to flex it down enough to slide over the thing, it broke. So I made it a little bit thinner, an extra millimeter. And let me share my window again. And whoops, I will turn that piece on. So there's the battery clip there, the sort of the darker gray part. And you can see where it goes and hooks underneath there, and that will help it, that will stop it from going up when it, and in fact, I probably don't even need this hook. I could just make it flat if it ends up being a problem, because it's really about stopping it from going vertically rather than keeping it from pulling back, because these two clips here do a good enough job of keeping it from pulling back. So anyway,
also throw a ridge right above it to stop.
Yeah, I could, but then I'd have to,
part.
then I have to reprint this part, and I'm trying to avoid that. That's like a 4-hour print job, and then I have to tap a bunch of holes and whatever, and so I'll do it if I have to. But I mean, the other thing I could do if I was going to do that is I could just put a little slot in here and just go back to using the original one that goes in. So yeah, we'll see.
I like that idea. That was what I was going to suggest, was the slot.
Yeah.
And that does two things, by the way. That, you know, whenever you have a straight plate, like you have there on the side, you know, you say your original one, if you pick up your original one and you saw where it broke, if you put a groove or a bump along that part that broke, in that area, it will, because it's not a straight across, it adds tremendous amount of strength to it.
Yeah, and I can do that, but then it's not flexible enough. See, the
It's gonna
issue
have to be
with that,
flexible.
yeah, and what I really need to do if I'm going to use this is to just cut this off
Okay, I
in
think you're thinking
that line and
yeah.
just take that out, because I don't need to clip around this side. All I need this bottom piece to do is to keep it from moving vertically. The clips on the sides will keep it from pulling back, you know, unless you separate them manually. So I'll see how this one works, and if it doesn't, then I'll either just cut it off or print a new one without that part. And that's really easy to do. You can just, oops, I can just create a sketch and draw a line from here. And in fact, I probably just go like this and go up vertical. And then I can just get rid of that part altogether and just remove it, and boom, now it's flat. So it's I can do something like that, and then and that should work okay as well, because then it doesn't have to bend at all. So I may actually end up making this a little bit thicker. So yeah, anyway, that's kind of what I've been playing with lately.
Normally we would do something, we're very cognizant of printing direction, but sometimes you really don't want to redesign your part, or it's difficult to have a different flat surface to print on. So another trick that we sometimes use is pretty simple, is just put some vertical holes so that you can throw a bolt or a screw up through the through the layers, and in such a way that you can then compress the layers down, so you get both the tensile strength of the bolt, as well as extra compression of the whole part.
Well, another thing too now is, since they've made it so easy, is plastic welding.
Yeah.
You know, you just stick a piece of metal and reinforcement in there.
So this is my RC remote control, and I have a GoPro camera mount that I designed and 3D printed that attaches to it. And the GoPro camera mount uses this sort of a quick release type thing. So it basically just, I can slide it on, and then the GoPro is held on there, and then I can film without having to hold the camera. I can film my car while I'm driving it. The problem is, in order for those two little overhangs to not break off, the layer orientation has to be this way, so that the strength is the layer lines are going around like this, so that these parts won't break off.
Yep.
But in order to make it that way, then this whole thing becomes very flimsy and easy to break. So what I did is I printed a hole in it.
Yep,
Basically, I think that's a 1/4 inch or 3/16 inch hole that goes all the way back, and I put a piece of 3/16 brass rod through it, and then there's a screw in here holding it in place. Not that you need that, because it's a pretty tight fit, and that gives it all the strength it needs, sort of in the bad layer orientation. So that has worked out really well. I've used this for a couple years now without having it break.
That's a good idea.
So that's another way that you can get around, when you need a full 3-dimensional layer strength, you can sometimes add stiffening parts to it in the bad orientation to compensate for that. Yeah, lots of fun.
Thanks, John.
You're muted, Ray.
I don't know if anybody goes to IKEA. Usually my wife and I will when it's really hot, just to get some exercise and walk around in the inside air conditioning. But anyway, they used to have, it was like a wall of parts bins, and they had all these unique fasteners that, like a rod with a threaded hole going up through the center of it, and you name it, all kinds of unique things that I've kind of used and for like reinforcement, but a PVC pipe, not a 3D printed parts. But one of those holds the piece of pipe that's in the center of the robot that I put the cameras and other things on. And they work really well. They're, all metric fasteners, but anyway, they stopped doing it. I don't know if I abused the situation or what, but going through there and picking parts out of the bins.
Yeah, I machine stuff like that when I need it now, which is handy.
Yeah.
Like the little brass rod that I have on the end of my motor holding my encoder. I machined that on my lathe. So
yeah, that's cool.
Yeah, I find that having a 3D printer and small metal lathe and a small milling machine really lets you mix things up. I mean, I 3D print almost everything, especially because all I print in pretty much is ABS, which is plenty strong for almost everything having to do with the scale of robots that we build. But occasionally I run into places where it's not enough, and then I need to machine something or want to add a ball bearing or that sort of thing. And so having that ability to do that as well is really handy.
Mm-hmm.
I see the Shoreline in the background. What type of lathe do you have?
It's a Shoreline lathe as well. It's
I didn't see it. Okay.
Right there.
Box over there.
It's underneath this box. That's
You got it. I see it.
Shoreline over there.
Yeah.
Yeah. So I have a manual Shoreline lathe and a CNC Shoreline mill.
Mm-hmm.
The CNC mills are a real pain in the ass to use. I would almost rather have a manual mill for, now that I have a 3D printer to print complex parts, because most of the milling stuff that I have to do now is really small, like, drill a hole in this piece of an aluminum so that I can tap it, or, take a little bit off the end of this thing or something like that, or square off this piece. And I don't normally anymore cut out pieces out of, complex shapes out of metal. Yeah, I mean, it's certainly better than nothing. And you can do manual stuff on a CNC mill. It's a little bit more of a pain. It helps if you know G code, and you can just punch in numbers and stuff and get it to, just do individual movements and things like that. I also have somewhere, it's not here anymore, but I have one of those dials. It's I forget what they call them. It's basically
a jog dial.
Yeah, a jog dial. It plugs in via USB, and so you can use that that actually plugs into my Raspberry Pi, and which I run CNCJS on, and it allows you to move it in preset amounts, or whatever, without having to punch in numbers, which is handy when you want to do sort of larger scale movements and things like that.
Okay, well, is that it for John?
Yep.
Okay, back to Mike. Are you ready to go, Mike?
Yeah. Well, what happened was I put my transmitter, RC transmitter, right next to my computer, and the Wi-Fi went bad. So it wasn't. I was thinking, oh, Spectrum Internet Service is doing it again, but it was just RF interference. Okay, so the question I have or advice I'm looking for is the in the design documents on Go Build a, they recommend or say and basically require a diode across the cutoff switch, because when I hit the if it's moving and someone hits the emergency stop button, the motors are going to back drive into nothing. There's no load there anymore.
Yeah.
And so they want a nice diode there to give a back channel.
Yeah.
So I appreciate that, but they also say I could have a resistor on there for pre-charging. So when this, like the battery's attached or something. So I'm sort of, I don't really like that because I can't leave the battery attached and just turn the relay off because it'll drain the battery.
Drain the battery, right? Yeah.
So.
Yeah. The diode thing I think is probably a better idea. That way, yeah, you do have basically you're, giving a path for the inductive kick to get back to the battery.
Right.
When you quickly turn it off. And but the resistor part, I don't know. I never did that. So, but I do all the diode, across the switch thing on all the platforms that I use the RoboClaws on, and haven't had an issue yet. I don't know if RoboClaws have pretty good warranties on them, but I think I don't know what happens if you don't put the diode on it and you say, "Ooh, this blew up. Can you can you fix it for me?"
Well, this is for theater, and it can't go bad. So I got to do all the protection I can.
Yeah. That makes a lot more sense to me than the resistor, because you're right. You're going to have to completely disconnect your battery, and otherwise it will drain it down. So
yeah. So I was thinking of putting this thing would have a 30 amp surges to get the motors moving. And the RoboClaw said that you need a diode with at least 1/10 of the surge current for the back EMF.
Mm-hmm.
So I got some 5 amp diodes, and I'm hoping those are good enough. Otherwise, I have to get some 15 amp diodes.
Why don't you just put a switch? Why don't you just put a switch right next to the battery as the first thing?
That's what I have, but when the switch.
If you turn the switch off, the battery can't drain.
Oh, another switch.
Yeah, another switch.
Yeah.
In between the resistor and the battery.
But then I need a resistor on that switch.
Yeah, you would.
But so basically no resistor. So I'm thinking no resistor for pre-charge. You're just going to take that surge current when you attach the bat when you do the initial turn on. And,
yeah. But not unless you're not unless your motors are on when you turn your robot on.
I think
usually you're not going to get that, right?
I think it's the capacitors in the RoboClaw controllers.
Oh,
the charges of the capacitors, and it's a big surge current.
Okay, yeah.
And I think they can handle that, and the wiring can handle it, and the battery can handle it, and the switch can handle it. But the diode I think is really important for reliability. So
yeah, you can blow out the MOSFETs on the RoboClaw if you don't have it, because you're getting this huge spike, and they're I think the ones that you were using, I want to say they're only good for like 34 volts or something.
Yeah, 34 volts, 15 amps, 34 volts.
Yeah,
all I need is like 9 amps, but that's the one I chose.
Yep.
Yeah. So
I dealt with the resistive pre-charge issue on my charging circuit for the LiPo battery, where it does have very large initial currents that surge into the LiPo battery, and the way the circuit will end up working there is used a relay to pass charge current from the converter into the battery, and you had the charge current, you had the pre-charge Yeah, the pre-charge. I'm sorry, I lost my thought. I need to recollect it. I'm sorry.
Okay, thanks. I can think of some complicated things to do, but I'm trying to keep it simple. But yeah, yeah. And then that's the last thing I think I have to do to the chassis. Before I put the top on it and try to figure out how to do the limit switches and make it work. So when it basically you don't want to hurt damage people, when you're bumping into people. So I want to be able to bump into someone and not do any damage. Because
pissing off your patrons is not a good thing.
Right. And so now that I've gotten that emergency project out of the way for a while, I'm back on my RC car, for Robo Columbus, and one thing, and I've been having this trouble because I put it back together and my serial ports moved positions, the Linux numbers, and so I was using serial by ID, but when I started using Docker, the serial by ID didn't work, and I sort of investigated into the Docker code or the see what was there, and it has all the stuff there, but the information from the host, the Pi, to the Docker that allows serial ID to work. So serial ID lets you know the ID of the device on there, and so I can. Normally, when I was just using, Ubuntu, ROS on Ubuntu, I would, or just Ubuntu, I would say, okay, go to the serial ID address with this big long string, and it would go find the right one, no matter what is TTY ACM 0 or 1 was. But when I put it in Docker, it couldn't do that anymore. And so it was like hard coded to ACM 1 or ACM 0. But what I decided to do is put a command for each of the controllers, an ID command. And I say, okay, what's your ID? It'll spit it back. And then I can go poll the serial ports that are available. And the one that sends back the right ID is the one I'll use for that particular node. So I'm starting to work on that code. And I think it's going to work. So.
Hey, Mike, does UDEV work in Docker?
I couldn't get it to work. No.
Okay.
And I couldn't figure out how to install it, but yeah. It sounded complicated, so I decided I'm just going to do this, which is a really nice thing to do because that way I don't even have to deal with that long descriptive string that I got to type in. I can just say, hey, the engine controller sends back an ID of engine, and the IMU controller sends back an ID of IMU, and I just, find the serial port that sends back the right ID. I think that's elegant, or maybe not elegant, but it's quite functional and easy.
As long as you don't have anything else plugged in that's a serial port that, like a camera or something where you don't have control over it.
Oh yeah.
That ends up messing it up.
Yeah. Spoil my parade. All right. All right. Well, but thanks. Thanks for the input on the diode and the resistor stuff. I'm done.
Hey, Doug, I got a question. The official cones are 18 inches long and they have a black base. Is that right? Doug?
I don't know if you were speaking, Doug. We didn't hear anything.
They do have a black base, huh?
I mean, I didn't buy this as an official cone. I bought this a long time ago, but it seems to meet the specs. It's 18 inches tall and it has a black cone.
Or black base, yeah.
Yeah, a black base. Yeah, the rules spell out. If you look on the PDF file, it spells out what the cone looks like.
Okay.
But yeah,
Yeah, I think the answer is yes. It's black on the base, if I remember.
Okay, good. Yeah, because the link that, well, I don't know. Last week, I think the link that Doug gave me showed 100% orange, base and top part. I thought,
We can look Saturday. At least I think, yeah, we can look Saturday. I'm trying to remember offhand, but look Saturday. Remember, remind to look.
okay. Anyway, I bought the ones with the black base because those are the only 18-inch cones they had at Home Depot. So anyway, that's good.
That is not specified in the rules.
It is okay.
For the Canadian guys, there's only 2 months left to get ready.
Are we finished with the list? Because I had one item to show on the list.
Yeah, we're done with our list of presenters. If you have something, Paul, go ahead.
Okay, let me just present. So over the week, I experimented with tail scale, which is a really, really cool way of networking together different machines that are on different network segments. And so the use case here is that Lobot is sitting outside under a tree with an onboard cell phone connecting his internet to connecting the Raspberry Pi's Wi-Fi to the internet over a cellular connection, and I'm in the house in air conditioning space on my home Wi-Fi with cable internet off to the internet, but the two network segments between the one that the Raspberry Pi is on and the one that my laptop are on are only connected at the internet level. And so the question is, how do you get them to look like they're like Mobot and my laptop are on the same network? And Tailscale ended up being an extraordinarily simple, or I should say, extraordinarily easy to use and install solution. And I posted a link to the video on how to do it. It's a 10-minute video, and it took about 10 minutes to get PyDog and my phone and XPS 15 is my laptop onto them, and they end up with these 100 dot something IPs that are not routable across the internet, but associated with the tail scale stuff is what they call a magic DNS that recognizes the name PyDog V, the V is for VPN, and routes it out. It's 100 dot something IP where it goes over VPN and ends up at the XPS 15V IP in my home. So super powerful for connecting remote, connecting things that are on different network segments, each of which is only connected to the internet. And Kareem talked about this a few months ago, and he's been using a package that is functional equivalent called Zero Tier. And he did more, I think maybe more analysis, comparative analysis than I did. And Kareem, feel free to add any comments you might want to make. But I just want to, my report here on this is that I tested it I've got PyDog with me, and I put his RPi 4 connects to the Wi-Fi hotspot on my cell phone, So I turned off Wi-Fi on the cell phone so that it wasn't connected to Starlink, so it was only going through the cellular network. So PyDog was talking Wi-Fi to the cell phone hotspot that then went over the cellular network off to the internet. And as you probably know, there's a NAT router in the cell phone provider's connection to the internet. So it traversed all that nicely. And then my laptop, the XPS 15, was on the Wi-Fi router connected to Starlink. So completely disconnected from the from the network segment that PyDog was on, going out through Starlink to the internet. And I fired those two things up, turned Tailscale on, and on each of them. And it took all of about 10 minutes to install Tailscale on each of them. And then I was able to fire up VS Code on the laptop and ask it to connect to PyDog V, which it did, going over the VPN out through Starlink into the internet somewhere, and then back into the cell phone and back into the RPi4. I was able to edit files on the RPi4. So I was like super impressed with how easy that was to do. And now the thing that I don't know that is crucial for us RAS folks is if we want to run Ubuntu. So Tailscale supports a wide variety of platforms, including all the cell phones and flavors of Ubuntu and CentOS and other Linux flavors, Windows, Mac OS, even Apple TVs and various other devices. The thing that I don't, and support several flavors of Debian on Raspberry Pi, including Bullseye and Bookworm and those various releases. The crucial thing that I do not know at this point in time, and do not have the right configuration to test, is if I put Ubuntu on the Raspberry Pi, do they have the right install software for that? The actual process of installing is real simple. You just run curl with a couple of parameters that downloads a install script and pipes it into shell. But if they don't have the right the right packages for Ubuntu on ARM, then it's going to fail there. So that's the unknown piece, which I probably won't get to test till I get home. Anyway, oops, I'm sorry, I didn't realize I wasn't sharing. Oh, I was sharing my management interface. Okay. Anyway, that's what I had to report was Tailscale producing a virtual network that gave me a flat network, a flat subnet across disparate disparate networks that were only connected through the internet. Did that make any sense, or was that too garbled? Uh-oh, maybe it's too garbled.
Yeah, it's. I don't know if it's. I don't know. Are you outside, Paul?
No, I'm inside talking on my cell phone.
Oh, okay. Yeah, sometimes it gets a little muffled and it's a little hard to understand you, but I think we got the gist of what you said.
Okay, cool.
It's just a great way to set up a private VPN for your robots that work across all sorts of boundaries, and you can go both Tailscale and what I'm using are both good ways to go about it. There can be some trickiness with getting DDS set up. It requires multicasts, and so you need to be. It's not like completely configuration free necessarily, but like in the ROS2 space, but you can get a lot of functionality. So yeah, I can remote control my robot from across the internet and send it joystick node messages and things like that. And so it's a very convenient kind of approach to take, and both of them seem to be very, very secure.
Good to know about the DDS stuff being an issue. Thanks for that, Kareem.
Yeah, you bet.
If we're into open mic, I have a couple of other items. First, I want to check John Kay. Are you going to be at the meeting on Saturday in time to bring the meeting kit?
Yes, I'll be there.
Thank you. And then Doug Parody, are you on the line? Oops, Doug.
Sorry, Paul, I didn't quite catch you.
Okay, I have a question for you, Doug.
I've quit thing.
Can you hear me? Can you hear me okay?
Not real well, but go ahead.
Oh boy. What,
You're not cutting out, Paul. Paul, you're not cutting out. It's just muddy sounding.
It's muffle would be the word I would use. So you need to be louder or more precise.
Maybe just speak into the microphone more in your phone. It seems like it kind of comes in and out.
How about this? Is this better?
Yes.
Yeah.
Oh, how about that? I'm holding up my phone as if I was talking to it on the phone. Okay, this is reasonable. Okay. So Doug, I was reflecting on the and I really like the idea that you've introduced in Nova Columbus of extending the upper end by introducing the no GPS and no coordinate aspects of where you can gain an extra point. The concept of opening up the top end is great, and those are great directions to go in. I think I'm beeping. Try that. I think there's an issue with the implementation, and I don't know how to fix it. But the issue I see is that if you have a robot, you want to kind of do its 3 runs in incrementing levels of difficulty so that you get the highest level of points that you can before it craps out. And the issue is that with the rules as they are, you have to declare at the outset that either you're using let's take the no GPS option, you're using that or not at the outset before you even try and reach the first cone. And that imposes upon you a constraint that you can't go on the course and take measurements for doing a GPS run before you would go and try a non-GPS run. So the issue that I'm bringing to you is that you can't, using the current rules, you can't do a kind of incremental advance to a more difficult level without risking everything at the outset and saying this is going to be a robot with no GPS and it's got to do everything. It's got to get all 9 points before you can hope to get that 10th point.
Nobody said it was easy.
Okay.
Okay, I'm not quite certain, and I admit I haven't read through the rules.
Let me put out like what happens. In actuality, really the thing that we don't want, you know, we have no, I can't tell what you put in your, I'm believing you when you tell me you only put in 3 waypoints. Okay. I don't know the intent, with no GPS is that you got to have a very, very robust optical avoidance and some sort of navigation system that's pretty reasonable, probably odometry. And, you know, but that's not necessarily so. You know, I have been able to, but most likely, yeah, most likely. So the question you had is, if I understand it right, is if I can't go out on the course, how can I go from the bottom challenge to the top challenge? I mean, excuse me, from the top challenge to the other challenges. Okay. So it's
to go to the more difficult challenges from the easier challenges?
I think that's what Paul's saying. He's saying that,
Yeah.
okay, I go out and I do at the bottom level, I put multiple waypoints in and no obstacle avoidance. I just drive to the cones and I get 9 points. And then I say, well, you know, I want to try it with only 3 waypoints or no waypoints, whatever you want to do. You want to try it. Okay. So in that case, since you've already gone out on the field, you know, you break the rules pretty much.
Yeah.
The way they're written now.
Yeah.
I think I can fix that. But you know, you have to, it becomes more level of faith. And otherwise that nobody's going to cheat, you know, that nobody's going to, nobody's going to.
Let's assume that we're all honest and we admit to what we're doing and all that. There's no cheating. I'm just saying the rules, as you said it, the rules don't permit that sort of like incremental seeking towards the highest point count.
Yeah, they're saying you go for, right now it says go for your highest challenge and then you can drop down to the lower challenges later. Okay. Otherwise, for example, you know, when we laid out the cones, you know, Scott looked at it. He was originally going to go for 3 waypoint only, but you know, he just looking down the hill, he said, nah, can't do it. And he dropped down to the next level. So
that's a point. You could do it in reverse order. I didn't think about that. That's the okay. Assuming that you didn't use intermediate waypoints on your first try.
All right. That's how you would, the way they're written now, that's how you would go about it.
Good,
so,
thanks.
So if you, whatever your challenge, your super challenge was, you know, assuming you really have a legitimate shot at the super challenge, then, you know, you do that on run 1 and 2, or, you know, hopefully you get it on 1, but if you don't get it on 2, then you might have to rethink your strategy and drop down to a less, you know, a less challenge.
Yeah. I didn't think of that way of approaching it. Thank you.
That's how it's written right now.
Okay, I've got a question. So without GPS and without, you have to assume that you have some prior knowledge of the course. Like if I'm just using odometry and a compass, I'm going, you know, so far in this direction. And when I get there, I should be able to find a cone, right?
Mm-hmm.
But that says you have prior knowledge of the course. I mean,
no.
Otherwise,
Well, you do. You know.
Yeah, you do.
Right, you
How
do.
else are you going to do it?
Let's take last year's course.
Yep.
Okay. You could tell where the home cone was. It's standing next to the start line.
Okay. Yeah.
Okay. So you got 1 cone right there.
Yep.
You also know where the first cone is because you could see it.
All right.
There's not, that's not guaranteed, but just because of the way Steve's land is laid out, you're most likely going to see. We don't have any intermediate hills we could hide it behind.
Oh, I thought maybe there was enough of a hill that you couldn't see the first cone.
I have a question then for the no GPS. What you're really talking about is no GPS sensor, correct?
That's
Or
right.
navigation.
So you're
period.
still going to get the GPS waypoints of the cones, and it's a
Right.
trivial matter in code to convert
Yeah, I mean,
the distance and bearing from one GPS coordinate to another GPS coordinate into an XY Cartesian grid.
Right.
That's really simple to do. There's code
But
on the
the key
net
is
that
you'll
does it.
have to calculate it. It's
So-
what it boils down to.
So there's no reason that you can't just, you say you're starting at this location, which is 0, 0, and that's this GPS coordinate. And
Right.
here's another GPS coordinate, and that's, 100 meters and 273 degrees from this one
all
kind
right.
of thing. And so
Yeah, so-
you still know where the cones are. You just don't have a sensor that gives you feedback as to where you are on the course.
But there's different levels, John. The first level is you do that with GPS added into your sensor mix.
Yeah.
Okay, so that's called the three-way point challenge.
Right.
All right. Then if you do it with your GPS turned off and you do the same course and you don't have it but those 3 waypoints, then you have the three-way point challenge plus no GPS challenge. You actually accomplish 2 of the challenges.
Yeah.
And the max you can have is 2 challenges because there's only 3 challenges, and there's no way you can do 3-way point challenge and the 0-way point challenge and get both of them. So if you think of it, bottom level person just starting off, he gets his mug. He goes down, he drives down the hill and gets 10 feet in front of the cone. He doesn't even stop. This thing goes on and ends up in the lake. Okay. But he went by the cone by 10 feet. So he gets a single point. He gets his mug. Okay.
You can use
Now,
it to bail out a robot.
The guy got a little bit smarter because he had to fish out his robot, and he made it stop. So he stopped within 10 feet. So then he gets 2 points. And just so darn lucky that he hits the cone and stops, he gets 3 points. So I'm talking about a beginner now, okay? A person whose robot is really, maybe all he can do is drive in a straight line. He can stand in the start line and get it kind of close. And hopefully when he gets down at the other end, he's close to the cone. Okay, so that's the bottom level person who would score a point. So the next thing he goes in, he says, well, dang, I stopped at one cone. Why can't I stop at them all? So he gets the 3 waypoints, but he realizes he has no obstacle avoidance. So he goes to intermediate waypoints to go around the obstacles. So he can get 9 points that way. So he can get he gets the perfect score of 9 points. But he might have used 7 waypoints. He might only use 4 waypoints. It depends on the course. Then, so the next step up, so he would just get perfect score on his mug. Okay. The next guy goes on there and says, I don't need all those intermediate waypoints. I just need the 3 waypoints. And remember, there's going to be obstacles in the way. So if you don't have obstacle avoidance, this is not going to work for you. You have to have some sort of obstacle avoidance. So if you have that, then you can get perfect score, 3-way point challenge. That's what's on your mug. Okay. And likewise, if you go to the next step up, you can say no GPS. I put that, the zero waypoint challenge, to me, you're going to have, where two of the cones are probably. You're going to have to search out that third cone with some sort of search pattern. You know what I mean? You do know it's in the first quadrant. So you have, it's not going to be out of bounds, out of the start line and the,
Actually, though, I don't think you do, because if you hit the first cone,
yeah,
you GPS wise, you know where you are at.
yeah,
you know what those coordinates were.
if you know what
So
the
that's
coordinate of the cone is.
kind of a reset, but that terrain is so rough. You really think anybody's going to be able to do that? It seems like with just a compass and odometry. That
Well,
seems pretty tough.
like you say, you know where you are, and like John said, you could calculate the distance and angle to the next cone.
Yeah. I mean, look at,
you could reset your gyro drift. Okay, so you got that all reset. You could,
I'd like to see it.
The answer to part of this is a Kalman filter. If you have a Kalman filter, it makes it a little bit easier, because you're not going to be as far off as you would be if you didn't.
Right, but look at David Anderson's JBot. I mean, that's kind of the top of the craft, but he very clearly goes over very rough terrain while maintaining really excellent odometry.
Right, he does. Yeah,
it's using encoders and an IMU, which is essentially a compass.
Yeah, he now has a GPS.
Yeah, but a lot of his videos, he's not using it, or he didn't have it.
Right.
The one where he does the hat drop and goes off 500 feet through the woods and comes back again, there's no GPS there.
That's exactly right. You're exactly right, John. So it is doable. Now I will say, if you look at that video, that one was a little better than Steve's yard, but that's okay. It's still a real accomplishment, and he has excellent obstacle avoidance. So not only did he go 500 yards, he went around obstacles in his way to go to 500 yards. Yeah, so it's a real, I mean, it's an incredible accomplishment. But he will tell you that video was like, he was astounded. He didn't expect it to happen.
Yeah, I mean, but the thing is you don't have to get that close in Robo Columbus. You have to get close enough that you can establish a search pattern to find the cone, and be within 30 or 40 feet of the cone, and you start going in circles and stuff, and you're going to see the cone if you're that close.
You're right. Hey, this is all doable. I'm not saying it isn't doable.
Yeah,
I'm just saying it's not falling off the log doable.
No.
You're gonna have to get to the, and like I say, what I guess someone's going to say is that the hardest one we've got now is the zero waypoint. And it really is searching for that second cone. All right. And even there, it's got to be in the first quadrant somewhere. So, but you don't have any, the first cone could be to the left, or it could be to the right of the second cone. In our case, it's always been to the left. Otherwise, the first cone's always to the left of the second cone, which is on the right side. But there's no reason why that couldn't be changed up.
So the zero waypoint challenge, I'm assuming you're not allowed to give any direction to the robot beforehand.
No, you still have the direction you set it towards at the beginning.
Right, but I mean, you couldn't say the second cone is in that direction and point. No,
you got to have some. You got to search it out. Yeah. And I'm not saying that's easy. I'm going to say the only reason that's in there, John, is because of you. You're the one that suggested it. So, you know, we worked it up and put it in there. So
Yeah.
that's like the, you know, the guy that does it with no GPS and 0 waypoints, you know, hot damn, that's pretty good. Yeah. So, but I'm not there. You know, I'm just going for the 9 points with multiple waypoints. You know, I'm just going to try and get a perfect score. If I get a perfect score, then I might go to something more challenging. But for the people, you know, but somebody like Scott, you know, back when Scott and David were running, you know, together, they frequently both got 9 points. Okay, both of them. And, you know, something about Steve's yard has jinxed Scott. And I think the best he did was this time with 8. And I still don't know why he didn't get that last point. I think his robot just lost it. So the point is, you know, he might want a bigger challenge. He might want to do a 3 waypoint challenge. He wanted to do that last year, but the way we set it up, he figured that he couldn't detect the barbed wire fence, and that he'd end up in the lake. So, you know, it was just a little bit. He figured it was a little bit too tough for him. So, anyways, I know I've talked a lot about this. I'm very enthusiastic about this year's Robo Columbus. I really want to see all these robots out there, but you know,
yeah, the thing that you know, getting back to what Paul was bringing up earlier, you know, from a logical standpoint, especially with a new robot like say mine, you know, I'm going to want to do the waypoint challenge first, and assuming that I'm successful at that on the first run, which is a pretty big assumption, then I might try something harder. But I'm not going to try the hard thing first, because if I try the hard thing and don't get anywhere, then I've basically wasted a run, and you know, then I might end up with no points because the robot breaks after that or something like that. I'd rather do something easier that gets me 9 points or 8 points or whatever.
That's right.
You know, and if I can't get 8 points or 9 points in my first run, then I'm certainly not going to be able to do a no waypoint challenge or something like that, which is a lot harder. So you want to do the easier one first, and if you're successful at that, then step up. But you don't do the hard one first and then step down.
Well, the way it's written now, you would have to do the hard one first and step back. I can probably rewrite that. I'll look at it and see if I can adjust it. I'll take this as good feedback. Like I say, the big thing you have on this is you have to trust that everybody will clear out all their waypoints between runs. You know what I mean? They'll actually do that.
You should be able to tell just by watching the robot whether it's reacting to an obstacle versus
but what are you going to do,
driving to a specific waypoint.
Yeah, you see the gun goes. You suddenly see the thing suddenly goes to a clearer shot and then turns and goes. You're going to call the guy out. You're going to say, "Hey, well, you know,
Yeah.
I don't want to be in that situation."
No, I understand, and that makes sense.
Yeah,
but that's no different from starting out with the most difficult challenge. It's honor system either way.
I'm sorry.
It's an honor system either way.
Well, yeah, to a certain extent, for sure.
So in the meantime, let's think about it, and Nesri, Doug, you'll report back. In the meantime, I have something I want to show. I found.
Okay. I'll say about it. If you know, I'll just make it very explicit in the rules that if you decide to change your challenge, you have to clear out your robots. You know, all the waypoint information.
Thanks for considering this, Doug.
Huh? Yeah.
Thanks for considering this.
Yeah, it's no problem. You know, we want everybody to have fun. That's the real rule.
Hey, I found the answer to Mike Williamson's question. If I could
go ahead
something and share that. So let me just let's share that. So are you seeing my battery box wiring diagram here, Mark?
Yep.
So
Yeah.
the way this pre-charge box works, that doesn't cause a continual drain through the pre-charge resistor, is it's a 66 ohm resistor that when you activate the on input which is meant to cheer. So okay, so a big picture view over this. Got a 400 amp relay here. This is the coil of the relay, and that switches power into 12 volt switched, which then can feed the inverter and all kinds of high power stuff. And what you're trying to do with the pre-charge relay is to charge up the capacitors downstream on this leg before you close the contactor to avoid arcing of the contactor and early premature wear on the contactor. And so what the way this pre-charge box works is it's got a single input called on there, which is used to turn the thing on, and then to request closing the relay and activating the contactor. And when you apply a positive signal to that on input, it puts a 66 ohm resistor between B plus here, which is wired directly to the battery, and this switched input, the sys plus input. So effectively, it places a 66 ohm resistor across the contacts of this 400 amp contactor. That pre-charges the capacitors downstream in the inverter and everything on this 12 volt switched line. And then after a few seconds, it applies 12 volts to the two wires going out to the contactor coil, which closes the contactor, and that way you don't get the arcing because it already charged up those capacitors through these two lines. Does that make sense?
Mm-hmm.
Oh yeah, I can do kind of stuff. It's just relatively complicated, but yeah.
Yeah. So anyway, that's how you don't have a pre-charge resistor continually draining your battery.
Mm-hmm.
Okay, thanks. That's what I wanted to check.
Yeah.
All right.
So I guess you could have like a low value, resistor, and let it charge through that. And then after a certain, simplest thing would be to let it charge up and then short it out with a relay.
Yeah, sequence.
Right.
The sequencer
Yeah,
or something.
Right.
sequence, right?
That's what that pre-charge box does.
Yeah. Switches are cheap. If it arcs closed, take it out and put another one in.
Yeah, I had to buy 3.
400 amp contactors aren't cheap.
Yeah.
Oh, that's true.
That 400 amp is, yeah. My 30 amp one is okay. Yeah.
I have a second question, if I may be permitted, probably for John. I was looking at this micro switch that I want to use for the bumper, and I found on Mauser, I found the part number, and Mauser's catalog had an EDA model, and it wasn't really quite an EDA model. It was a link to an EDA library downloader that apparently on some CAD programs and maybe some PCB layout programs, you can integrate this library loader into the tool, and then you can somehow get it to download a CAD model from Mauser. I assume DigiKey has the same thing, and so the question is, how do you do that on Onshape?
Yeah, you can just import it. So basically, I mean, I can show you how to do that on Saturday, but it's really straightforward. You just import it into a new part studio, the part, and then you can, in your existing part studio, the one that has your bumper or whatever, you can just create it as a derived part, and it just basically copies it into the that studio as a separate part. I do that all the time.
It didn't actually have the EDA model itself there. It had a library loader linked. So I was like, okay.
I don't use Mouser for stuff because DigiKey has better shipping to Canada. So in general,
maybe I'll
I
look
just
at
use
DigiKey then.
yeah.
Okay. Thank you.
Okay. So let's see, can we pick? So yeah, I found something I can show you all once I click on the right link. So, here we go. Good. So I found this Thingiverse. So it's a robot dog. It actually looks sort of interesting because of the hinge system that you can see there. And they actually have a pretty good write-up of it. So let me click on that window. So here's the parts you need. And there's the leg in more detail. So I thought it was especially interesting how they did the linkage for it. And then from there, yeah, they go into, as I said, fine detail about the mounting of the servos and the linkage of the leg. And there's actually a better picture. So they have code for it and that. So it looks very interesting. I'm very tempted to build one of these based on what I'm seeing here.
So it's more of a leg that can actually take a step.
If you look at the leg, I mean, it's much more realistic. That this one's connected to pull on the back, and that one's to push that forward. So it's all hinges right there. That's why I said it was an interesting design.
Yeah, it looks like a fairly standard parallel linkage 2-axis leg. It is interesting how they did the top servo there connected midway on that. But yeah, that's something very similar to that. You'll see a lot of like where you have brushless motors, you'll have two of them sort of stacked in parallel, and the arms going out like that and then down and joining, and you can get the same kind of motion.
John, do they have a video of it moving?
And I'll look. They didn't on the other spot, but they may here. Because you notice they were very detailed on math and everything else about it. So they may actually have a video. Not there. Rockamo. Leg. Nope, not there. Let's see what they have at the top.
What about on Thingiverse?
Let me go back to Thingiverse. Well, there is just a model, and basically says code galère, how to assemble. I think that's where I'm at. Oh, maybe not. Yeah, I think that's where I'm at. Yeah, that's that one. And then the other one's just the code telling you GitHub. So they may at the very tail end. Let me click log. And
yeah, they don't generally put movies in there.
Occasionally they do, and occasionally it's on the back end, so that's why I was clicking along. So nope, sorry on that, but it looks good. It looks very nice in detail. I mean, even talks about the power load level in the battery, and somewhere in here there was about how much it would take for the power to run it and stuff like that. Somewhere in there was even about power load. I saw, yeah, right in there, he talks about power load levels. Yeah, it looks like it's a very well documented, detailed one. I thought it was a very good, yeah, layout.
Okay.
That's about the only thing I have at this stage.
You know, I think it's the Go2W is only $1,600, and I'm kind of hoping to see someone get one, so you know we can watch them play around and stuff. So, anybody interested in that? Has a spare $1,600 they want to blow on a robot dog?
Hopefully
Is
this
that
thing
the-
could go cheaper.
Is that the Xiaomi one or
I'm not certain.
Unitree or?
It looks like the name of it is just Go2W, and that was the one that was $1,600. But the one that has wheels on the end of its legs.
Oh, it's the Unitree one.
Yeah. Yep.
Yeah.
Yep. Maybe one of you guys will want one for Christmas or something, and you know.
No,
Keep watching Goodwill. Maybe you'll find one.
Say that again.
Keep watching Goodwill. Maybe you'll find one there.
Oh yeah. After a while, they're going to show up there.
Yeah.
Of course, I don't know if I'll be alive then, but
now isn't the Unitree the wheeled one? Doesn't that cost extra?
oh, for the wheels, I
Yes.
kind of got the impression that for 1,600 it included the wheels.
Yeah, I believe the 1600 was like for the baseline model without the wheels.
Oh, really? Okay.
Yeah, because the wheels are going to add 4 extra motors.
Mm-hmm.
And I looked on AliExpress for that Unitree robot dog, and for it ranged from like 2,000 to 2,400. I've heard that there's an additional fee for like overseas, like to the United States. So yeah, but even at then, like for around 2,000 ish, that's still a very good value.
Mm-hmm. Yep.
Now, have you heard of the Unitree's G1 humanoid robot? It's the one that they price at around 16,000 ish.
Oh, yeah. Does it look like it has no brains? It's just like a curved face.
I think so. Yes.
Yeah, it's kind of odd looking. It doesn't have like a traditional, I don't know, human-looking head. It looks brainless.
It saves on cost though.
Say that again. Oh,
I'm
maybe.
sure
Yeah.
cost.
Yeah.
I mean, for 16,000 for the baseline model for so a fully functional humanoid robot is pretty impressive.
I guess maybe Kareem's not still on here, but I thought maybe, he'd be interested in one or something. So
Now, did you have any personal ideas yourself what you wanted to use the little robot dog for?
no, I think it'd be, if you had to go to a moon day or something, that would be pretty impressive. I don't know that other groups would actually show up with one, but it's all just a matter of money. So
Yeah, I mean the problem with those ones, a $1,600 robot dog. I mean they have 12 brushless actuators, so you're looking at basically around $100 a piece for the actuators. And what some people that I've talked to who have bought some of the cheap actuators, they work great in the beginning, and then the gearing ends up wearing, and you end up getting a lot of backlash in the gearbox, and
yeah.
after a very short, after like a couple months of use, and then they're no good anymore.
Oof.
Now, was this for the Unitree robot dog or a different actuator?
The one that I heard about was the Xiaomi Cyber something or other. It's the one on Ali. It's about $80 or $90 US.
Okay.
the actuator. It's a brushless gear motor actuator for robot dogs, and but all of the low priced ones are going to suffer from, you know, using cheap metal and stuff like that, because, well, let's face it, they don't cost enough money to use good metal. And it's the same thing with RC car parts. You know, when you buy cheap RC car parts and you thrash the hell out of them, they break and they wear and you lose teeth and all kinds of stuff. And you have to spend a lot more money to get something that's robust.
I guess the old adage is you get what you pay for. So
Pretty much, yeah. Anyway, I gotta go. It's late here. See you guys.
where is Paul?
Paul is on the phone still.
Okay.
Does anyone else have anything to talk about tonight?
Nope.
Now
Hey,
we call it a meeting.
Paul, can you hang on after everybody goes? I wanted to ask you some questions.
Yeah,
Sure.
yeah,
Okay.
sure.
Oh, sorry.
Okay, Paul, are you able to stop the recording, or I can just
Yes.
stop the recording and then you guys can hang up whenever.
Sure. You can stop the recording, Pat. Thank you.
Okay, guys, I'm going to be signing off as well.
All right. Bye.
All right. See you guys.
Bye now.